Welcome to Acids and Bases Notes. While you view this presentation, take your own notes on acids and bases. Be sure to include definitions, properties, common household examples, and how to read them using a pH scale. You may pause at any time to take notes or go back as needed. We will start with acids, which are substances that produce hydrogen ions in a water solution. We represent hydrogen ions with a capital H and a plus sign indicating the ion or charged particle. Remember from yesterday that ions are an element that has more electrons or less electrons than the normal element on the periodic table. Because this is a positive sign, this means that this hydrogen has more protons than electrons. As you can see from the picture, when you add an acid and water, it's going to dissociate into different ions. If the solution has more H pluses or hydrogen ions in the water, then you have an acid. Bases are substances that form hydroxide ions, or OH minus, in a water solution. Hydroxide ions are represented with a capital O, capital H, and a minus sign indicating the ion. If you put a base in water, if the OH molecule comes out, then you have a basic solution. This list of properties is extremely important in identifying if something is an acid or a base. This will be on your test. If we look at acids, there are certain properties that identify it as an acid. The first thing is a sour taste. This does not mean you go into lab and taste anything. Remember, that is unsafe. But think about lemons. Lemons taste sour because they are very acidic. Acids also turn litmus paper red. We will talk a little bit more about litmus paper, but it is an indicator to tell us if it's an acid or a base. Acids also have a pH less than 7. Again, we will talk more about the pH scale in detail later. Right now, just know that it's less than 7 for acids. And acids also react with metals. Think about your corrosiveness of acids. We know that acids corrode things. Bases are pretty much the opposite. They have a bitter taste. So this is why people flavor the antacid Tums. Without the flavor, they would be really bitter and nobody would eat them. They turn litmus paper blue. They have a pH greater than 7, and they have a slippery feel. So think about cleaning supplies like bleach or soap. They have a slippery feel. That's an indication of a base. Both acids and bases are very corrosive when strong. As part of learning acids and bases, you will need to be able to identify examples in common household objects. This is a list of the most common found in normal households. On your acid side, we have most food and drinks are acids. Lemons, oranges, lemonade, vinegar, things that we use in our daily eating habits are acids. Stomach acid has acid in the name. It's very acidic. We also know that batteries have battery acid, which is why over time batteries can corrode and you see that battery acid leaking out. Bases, on the other hand, are your common cleaning products like bleach, baking soda, Drano. Also your antacids. They are called antacids because they are anti-acid. These are your Tums. Soap is also a base. Alright, real quick before we move on, let's talk a little bit about what makes a strong acid versus a weak acid or base. So a strong acid or a strong base has 100% ions in the water. That means that if you pour an acid or a base in water, it's going to completely disassociate, meaning all the hydrogen ions or all the hydroxide ions are going to come out into the water. For an acid, a pH of 0 to 4 means you have a strong acid, like hydrochloric acid or HCl. For a base, having a pH between 12 and 14 indicates a strong base, like sodium hydroxide. For a weak acid or base, you're not going to have 100% ions dissolve. you're only going to have a few ions come out in the water. So just like this picture shows, we have our acid, and then we have a couple of hydrogen ions dissociated into it. Not all of them have dissociated yet. For an acid, a weak acid would be a pH of 4 to 6. A base would be a pH of 8 to 11. This slide is a great overview of the differences between acids and bases. Take a look, take some time and read through what the differences are, and it'll help you review the differences between acids and bases. Now that we know what acid and bases are, let's talk about measuring them. When we measure how acidic or basic a solution is, we use the thing called a pH scale. When you write pH scale, it really is a lowercase p and a capital H. The pH scale is a measure of the concentration of hydrogen ions in a solution. The capital H in pH actually stands for the hydrogen ion. This scale measures how acidic or basic a solution is. It ranges from 0 to 14, with 7 being in the middle. Anything that is 7 is considered a neutral solution. Anything below 7 is increasing in acidity. Anything above 7 is increasing in alkalinity, or it's basic. Since the scale is measuring the concentration of hydrogen ions, the more hydrogen ions it has in the solution, the more acidic it is. Over on the alkalinity side, these have less or few hydrogen ions. If they have few or none, you are considered a base. This is a good picture of some common substances and their pH. Again, our scale ranges from 1 to 14, whereas below 7 is more acidic and above 7 is more alkaline or basic. Having a pH of 7 is neutral. Water is always neutral. On the acidic side, you can see that most of our foods that we eat are acidic. Lemons, for instance, have a pH of 2, which is much more acidic than bananas, which has a pH of 5. On the basic side, we have our cleaning supplies, such as baking soda. We can see that baking soda at a pH of 9 is much less basic than, say, bleach, who has a pH of 12. Now that we can read the pH scale, let's look at testing pH using different indicators. An indicator is a substance that changes color in an acid or a base. Mentioned earlier about litmus paper. For example, if we have blue litmus paper in an acid, it turns red. We also have red litmus paper. Red litmus paper will turn blue in a base. More often, we will use something called the universal indicator paper, which has various colors that match each pH specifically. I use these to test fish tank water. Basically, you take a strip, put it in water, and it comes out a certain color. You then would take that strip and match it to the color on this chart. If it's close enough to one of these colors, you then know the approximate pH of the solution. Remember, anything that's below 7 is considered acidic. Anything above 7 is considered basic. A pH of 7 would be neutral water. The last thing we will talk about is this thing called neutralization. This happens when we combine an acid and a base. Remember, when we do chemical combinations, properties change. So putting an acid with a base creates a salt and water, bringing the pH to 7, or neutral. So this is what happens in our stomach when we have stomach acid buildup. We want to neutralize the acid in our stomach, so a lot of people will take an antacid, like Tums. Putting that antacid, or that base, neutralizes the acid and turns it into neutral water and a salt. Okay, that's all for the notes. Now you'll need to complete the handout on acid and bases provided in Station 1's folder. Yes, you need to use color. If you have any questions, feel free to ask me.